everybody. So, well, I didn't know how to choose the right title. So, in fact, we will speak about scalability problems we have up to during the last 15 years and about system testing. So, in fact, we have a lot of POC. Well, in fact, I have a lot of stuff that I cannot share here at all. It's not public. But so there are so many stupid problems and so problems about testing and so on. So, well, some stuff I can share. So this is the Oracle most stuff. Few slides are really old, so because people asked me just to not forget about. So if I asked myself why I have a title, are you Dimitri? So in fact, when I started to write the first blog post, I wanted to be anonymous. And people started to claim about, so other Dimitris coming to discuss with me and so on. So, well, finally, yes, it was me. And so I worked in some benchmark center in the past, started to use MySQL from very small versions, so it was just for fun. And in 2011, they proposed me full job. So you do your stuff you like and you already paid for, so it was just great. So my blog is still here, but during the last 5 years it's mostly no news because everything MySQL internals, it's not much stuff I can show. I don't have any more Twitter, so it's since Russia started the war in Ukraine, so I shared stuff about horrors they do in Ukraine. So the house of my mother go in fire with Russian missile and so on. So they blocked my account. So you cannot find me anymore on Twitter, but well. Today, if you don't support Ukraine, so Russian war will come in your house, and probably for them will do, in which Ukraine saw. Slava Ukraini, and let's go. So what I will speak. So my focus mainly on standalone MySQL. So sometimes it's confusing to people because you always need to do replication. I also work with these guys, but my focus is about this. So single server, single MySQL instance, and so on. And this is how, well, in fact, it's amazing because the most used MySQL instance on any cloud is single instance, without HA and so on. So, well, it's about this. And, well, I added few slides to wake you up. So it's from the, probably it's 20 years old, about scalability. It's kind of starting like this about why we need it and what happens. So, well, if you start your very first website on something like this, it works. So everybody happy until you don't start to have a success. You have more customers, more users coming, and if you don't keep your load anymore, then you do something more sophisticated, but still there's more charge and so on, and it's not scaling, and once again, you invent more stuff, and it's still not so, and once, you can follow with Amazon. So Amazon started with Sun macro system. It was a huge, expensive service, and before they moved it to Linux and so on, but you, example with Amazon Fuels. So once you have a lot of users, so well, you need to test your system and validate if it will scale or not. And don't forget about this slide because at the end I will have a reference to this. So, well, even you have a rock solid stuff, military class, but well, there is still somebody to break everything. So, what about scalability? So you see, well, it's MySQL 8 today. So we have system 192 cores, it's not the end. So you have 256 on ARM and so on. So in short, well, you have resources, you need to do more work. So when you saturated resource, you can do more, it's fine. So people confuse it about scalability and efficiency. So of course, if you can do more with less, it's great. So the main point is, okay, you have more CPU power, okay, do more. You have more CPU cores, you can do more. Don't be confused that once you reach saturation, okay, you can decrease. But you have other solutions, you have thread pool and so on, to protect you from going down. So 8,000 is kind of our expectation to keep this number of connections. It can be 20,000, 32,000, it's not a problem. Well, you see, this is kind of with testing without prepared statement, realistic going by a p-port. If you want to go with prepared statement or use enterprise, you can go 4 million queries per second. It's not a problem. It's about primary key lookup. So you will see it's not always simple. So this is what you can do. Now then when you run a production, try to understand why you can reach this one, right? So if we look how MySQL was changed during the last 15 years, you've seen MySQL 5.5, it was just initial release with Oracle when InnoDB joined the MySQL team and so on. 5.6, it was the first improvement, big improvement with adaptive flashing and so on. But imagine the read-only your select, if you don't have any changes in the database, it was slower if you run some updates. So just because there was so big contention inside and all related to read view. So if you don't have writes, you don't scale. If you do writes, so you slow it down a little bit, this contention, you go faster. In 5.7 it was fixed. In 8.0 we focused on efficiency to get more throughput and have better results on the same hardware. And it was the first time it was continued release. So during this 8.0 time, you got new double write, new read log resize, log management, and so on. But amazing was, and reality was pretty fun. So before we was blamed that development is going slowly, so we made continuous release, happy, then people not happy again. So we cannot follow because you change too much, and it's every time you have changes, so shit. Okay, so we made LTS release. Now you have only security changes, you have innovation release, and so on. We did not scale, so MySQL 5.1 scale it on two CP cores, that's all. 5.5, it started to be better, it was 8, 16, and so on. But it was always a problem. So I have 90 things to work. Today I have many cores, don't scale. Today what we have? People asking for 2 cores on VM, on Amazon, whatever. And holy shit, 5.1, it was so fast. Why spend all this work? So it was, but in fact, it's not easy to scale. When you want to scale your code and be efficient on the same time, it's always a problem. So because to be scaling, you need to add some additional stuff inside. So you lose efficiency always. But also then, we started to have claims, so it was good enough in performance. I will not give you the name of the pretty famous guy, but I don't want to blame him, so it's a nice guy, but well. So people started to have it not in performance anymore, we need flexibility and so on. The problem is about response time. So this is like your entry ticket. If your response time is bad, so nobody will want your shit. And it's about a balance. So it's amazing, well, I was all my time fighting for performance, and then you realize, well, it's fine. If you're going fast, it's good, but if you lose your data, you finish. And in fact, this is a problem of balance. So you cannot get everything. So if you want to have lower cost, okay, it's it's the same piece of stuff. You have lower performance, probably you lose safety or performance. Choose. You want more data safety, so it will be more expensive, and probably you lose performance, but well, data safety will dominate always. So once you get your entry ticket with performance, then you can manipulate everything else. Well, that's why, performance is still on topic, whatever happens. And now about limitations. So I'm not here about to explain how you can tune your query and so on. Once it's optimized, so you go on the light speed, okay, your query is very fast, fine. Now why it may not scale? So one of the topics is about your malloc library. So if malloc library is not scalable, if you still use gmalloc, it becomes better, but tcmalloc on gmalloc is always favoring you. You will have more story about this. If you want to use persistent connect or reconnect, so it was mentioned already several times, has a cost. So you will not scale if you reconnect. Well, it's still scaling, but you lose efficiency. Okay. SSL overhead, I will give you more details about as well. Adaptive hash index, it's very good stuff on low load helping, but it's down to not scale. So in fact, and in MySQL code, you also have read-write logs, which by definition cannot scale. Just because you have counters inside. So even if you do only select, so you need always increment on the decrement counter inside, and you will get contents from CPU cache. It's not visible, but you run and run shit. It's not going up just because your CPU, and nobody's telling you about CPU. You can see in the internal count, but not directly. Primary key is mandatory, and I don't know if you are aware about difference with primary key and secondary key. So you have point select, so it's like select where ID equal value. If ID is primary key, so you have the red line, okay? If it will be secondary key, you have a blue line. So you see the difference, okay, 20-30%, fine, right? Now if you do the range, the difference is, so if you can see here, it's huge. So it's still faster, okay, if you will run, so we do the range of 100 values. If we'll do point select for 100 values, okay, you will have, if you need to divide by 100, so it will be a million divided by 100, lower than 400,000 like you have here. But as soon as you use secondary key, what we have. The question now to you, who is scaling, who is not? What's your opinion, red or blue? Red is scaling? See, guys, wake up. Scaling or not?
Not scaling.
Okay, fine. Blue is scaling?
Yes.
Good. So in fact, both are scaling. This is just less efficient. So, well, it's a good answer. The confusion here that you don't see CPU usage. So you don't know, well, probably CPU, it's not using CPU and that's all, but what kind of a problem you have inside. Well, this is about when you have read-only, only select, okay, it's fine. You see, whatever storage you use doesn't matter. Everything in memory, you're happy. Now, when you starting to do writes, first, scalability problem is read log write. So just imagine it's yes, question.
I was just to say, so you said scaling and they do scale to a limit because later on they
yeah, because the CPU is saturated and you just cannot do more. So that's why it's not because you are scaling, then you have a solution, right? So you can say, okay, I have million CPU cores and you will reach this level you expected, but nobody will buy it because expectation on efficiency on response time is too. So you need to keep in mind that all your writes are going to redo logs, and it's just single thread write into single file, and all your throughput just depend on single file writes and so on. So you may have storage which has huge I/O capacity, doesn't matter, because you are playing just with one file. If on this file you cannot write faster, you don't have latency enough, you just lose performance. So redo log efficiency, in NATO we changed it to have log-free design and so on, redo threads. But when you have a small machine, so having too much threads, it's not efficient. It's more efficient to go back to the old model, again, MySQL 5.1. So then you disable redo thread and let user thread to do redo log. Because once user thread has a CPU, it's already on CPU, so switching has a cost, and it's already on CPU, he can do small work for redo, and it will be faster than if you have thread. So you will say, okay, I do some job, wake up now, redo log thread, you can do your work, and redo thread will give you, okay, I do my work now, you can commit and so on. So well, this is about this. I have a long blog post about this if you're interested. It was last year, I think. Read view log contention still here, so as soon as you have writes, so when you have only select, you don't impact it by review because there is no changes, so you don't care. But if you do you started to do just one update and you have millions select around, everybody impacted by review. So you have this contention, you just need to live with this, I keep this in mind. Log manager was improved, but it's still here. And the problem you cannot solve naturally when you have data contention. So like on eBay, for example, everybody wants to buy the same iPhone, everybody fighting for the same record. So you will have, it's by design. So we have new thread pool which can solve his help because it will limit number of active transactions, and so it will not let performance to decrease. So you can keep on the same level. So if you have 10,000 connections, nobody can make the situation worse. And you have binlog impact. So binlog you need to keep in mind, and in binlog you always write after redo. So first you write to redo log, you prepare your work in redo log, and only then you write in binlog. So if you have a lot of writes, it will be at least twice slower. So you do redo log, then you have binlog, and only then it will be taken. So to see the impact, well, this is a mixed OLTP read-write, sysbench read-write workload. So you can see already on top line, so 40,000, 80,000, so you see on high load, on high system, okay, impact is big. But when we have only 16 cores, you see 32, it's pretty similar, so you can say it's good. But keep in mind, it's always depend on workload. So OLTP read-writes, we have many select and less write, so it's fine. But if your workload is like TPCC, you see already on 16 cores and 32, you already lose kind of 30%, but then there is no gain anymore. So 64, whatever number of cores you have, you're always worse. And it's huge, so it's 60%, you're twice worse, 3 times worse, and so on. So, well, if one day it will be improved, we'll be winners of the world. But let's see, it's expectation. So, as long as still this is in memory, so it's fine. You can tune redo log space, adapt your page flashing. So keep in mind that I/O capacity tuning is only 10 Zs. When you move to I/O bound, well, it doesn't matter. So everything will be ignored. But redo log size, I/O capacity, so you may only wait. You see, our user threads have no reason to wait for something. Your page flashing is going in background, redo log writing in background. User threads just committing and they don't wait on this because flashing is background process. You may be impacted by purge lagging, so if you see history range going up, because your undo pages until they're in memory is fine, but when you don't have any more free pages and so on in buffer pool, it will go to the storage. And then we start to read, write, and so on. Today have auto truncate undo, but during truncation it can be impacted. So we just go slower during this truncate period and so on. Change buffer remove will not help you because well, it will do initial work, but it will do merges. You can be impacted. So that because merge, so you may have drops in performance and so on. So it's always need to keep in mind in memory. You need to use it or not. One point which can be critical is to use null value for your column number. So if you use null, keep in mind that there is no space reserved. And once you will update the column, you will need to write this data somewhere. And you don't have space in your page, you will get split of the page. And when you start in your database, all your data have null columns, and then you start to write something, it's getting massive page split. So this is a TPCC workload. By definition, by TPCC standard, you have to use null, but if you use the right default, so you will not need to split the pages, you can do update in place, you have twice higher data performance. So to be honest, well, I have detailed blog if you need about this, how to use it, because in every query when it's not null and so on, you can use default, equal default or not and so on. And if you have good default values, you solve the problem. Now if you go to I/O bound, oh shit. You totally depend about your storage. So I/O capacity tuning doesn't matter anymore because you will be mostly in the reflection. So you need to keep in mind there is a balance of storage. So to read something from storage, you need to have free page. To have a free page, you need to flash dirty page or evict something. So in fact, you have a balance between read and write. So you write something, you block your reads because there is no capacity on storage to read. So if you write too much, so you can read faster. So then you have 3 pages, but nobody can come because storage is separated. So this is about all this balance to keep. You need to read and write on the same time. So about this design, there are a lot of speculation and discussions about should we need single page flashing, for example, because user thread comments, there is no free page. I want to read, but I don't have place in buffer pool when I can put the data. So today we have this single page flash that user thread can say, okay, flash 1 page and I can read 1 page to the memory. So at least we don't lose CPU cycles. Now, is it good or not? Well, discussion. So it did not change right now, so you just, it happens, you can follow and monitor to see how many single page writes you have and so on. You need to use double write today. So mind then, okay, when you test and you have just one NVMe flash drive, only one, so it's fine. But if you want to have 10 terabytes or more, you cannot just have one write for this. You need to have more, and you need to use write. Once you start to use write, whatever, 0, 1, whatever you want, mind and double write buffer is small. So if you don't configure, if you configure with many files, you will just write on the first drive in your RAID. So in fact, you will limit performance of double write to single device. Even if you have 10, you will not use them. So you need to use the smaller stripe size and at least not more than 2 files for double write and have big space for it. So at least it will be threaded on several devices to give you more performance. The good news on Oracle team working. So I don't know why atomic writes, there was discussion for so many times. Fusion had implemented this already in the past, it was 15 years ago it was implemented, but it was not open source. So people wanted atomic AI, and finally Oracle team decided to do it. So it's pushed to mainstream, it will be available to everybody. And well, one day we will not need the double write anymore. So change buffer helps. This is a good point, but you may have side effect. So Ninebone is really helping. You can get something, you will see some results, something like 20% improvement. So it's pretty significant, but currently we don't enable it by default now since 8.4, but it's fixed in 9.2 because on the recovery process you may have some problems. So it's fixed now, and I think it will be all okay. So you can safely use it. You still have file system contention. So this is stupid contention, but it's here. So every time we want to read from the file, we have a lock. So faster we have a storage, more lock contention we have. So well, it was sharded. So Sally made these changes, but sharding is not enough. And you have one hot table, so it will be still getting, you still getting contention. So you can do partitions. In this case, you will speed this contention. And also compression helping you. So you can do less I/O for the same stuff. So, but you will use some CPU, but it's still efficient. Yeah.
You mentioned the storage stripe size. Like,
yeah.
What would be your recommendation here?
At least 256 or even less, up to you. So because, well, MySQL server target is about all CPU, right? So, well, if you want to do decisional queries, so it will be full table scan or whatever else. With bigger stripe, you have better performance. Well, it's not focus of MySQL. It was not designed for that. But, well, it's still up to you. So if you have a lot of writes, or, well, at least you write intensive or not, so your double write will, you write all the time inside. So it means you always do twice writing. So once you write a double write, and you write to the storage. So if your stripe is not covering, or double write not going through more than 1 gig, you are blocked by performance on just one and whatever you have. If it's network storage, it's even more dramatic. Okay.
Do you need 256?
Well, generally people use red 1.0. So in fact, you have mirroring first, and then you have red 0. striping on top of your mirrors. Because RAID 5, you lose something, well, if you know a checksum and something, it's always tricky. Whatever, software or hardware mirroring. So RAID 10, so mirroring between two devices, and RAID 0 on top of that. Well, if you will take, let's say, Amazon, right? I prefer Oracle, but Amazon. So you have one volume because it's already secured, right? You have 6 devices, it's already secured. So we can do RAID 0 on top of several devices. So because with one you're limited by some IOPS, but if you take 10, will be probably still cheap, but you build RAID 0 on top of them, you have better performance, more IOPS, but you need to use small stripe size to be able to use them in the low writing thing. So. And now we move to systems. Okay. Where is Peter Zaitsev?
Running.
Running. He's never very sure. So in MySQL, first of all, when you decided to test systems, so people come in, okay, what system we can use for us? So we need to have a production, we want to have this and this. Okay, let's start. You want to run the test, you want to decide what you want. So first, the good news from MySQL 8.4, we have auto-adaptive default of it. So you just use the default one, okay? And so you see in 8.0 there was product management solution. So we introduced a variable about in the dedicated server, but it was Devil's born baby because was just did not help you much. So it was not auto-dedicated, so it was just few values inside, and it was insane values. So we could suggest people to use it, but there was no reason. Now from 8.4, so we have auto-adapted buffer pool size, buffer pool indexes, page printers, and so on. So according to your system, which you have, it will auto-adapt your config. So, and data safety first. So as I told, we pay attention about data. So transaction commits and winlog, everything is by default. I know that some people expecting that, okay, I have group replication, I have replication, whatever, I can relax my security. So we got long discussion internally, and replication team was, initially they wanted to have, okay, let's relax, we'll go faster. Finally, they understand that it's a huge risk, you can lose all your data if you relax your security config. So don't change transaction commit to true, no, relax, do not sync, and no. Or every changes will be fixed on the storage, and then only this way you're safe. So today, if you want to test, and this is especially for Peter Z. So because Peter mentioned yesterday that you need, 100 options, 100 parameters to make MySQL running fast. It's 2 lines today, okay? Just put if you want to use default max connection, only 1. Okay, but if you have a lot, so just max connection, that's all. I will be honest with you, try also to test MySQL enterprise edition. If you don't pay, you cannot use it in production, but for testing, you may see something interesting for you. And if you do pressure on Oracle, we tested enterprise edition, we want the same in community. More people will ask once it will happen. So today, I guarantee you it's faster. I cannot say why. So even if I'm drunk, I will not say why. But try it, so you will be surprised. So about all this regression complaint and so on. If you see the benefit, you can put a pressure on Oracle, give us this for community, and one day it will happen.
That's a bet for tonight. Right?
Yeah, question.
What does it mean, auto-adaptive? Just when you start MySQL initially or on the go?
Yeah, when you start it will. So in fact, it will check how many memory you have. So 75% will be go to buffer pool, or you have an adaptive formula. It's very small. You have a limitation inside. So if you have only 1 gig of memory, it will use half and something like this. It will check how many CPU cores you have. So according to this, you will have number of page cleaners and buffer pool instance, and also read log size. Because read log size also, more CPU cores you have, so more transactions we can run in parallel. And read log size will be big enough to accept all this parallel work. So,
Later on, depending on the workloads, it doesn't do any job on.
No, it started with these parameters, that's all. So if you change hardware config, it will be readapted. So you have nothing to do. So today people, when they have different shapes, virtual machines or bare metal, you just run with that. You can always find something more optimal, right? So just default. Imagine default in the past was for a laptop, right? So we got people, I improved your MySQL config, your default is not good. We know it's not good, it's made for a laptop. So you see the first changes which were made to improve, like for big servers, all developers at MySQL were crying because you start on your laptop MySQL server, your laptop is died because no memory is vacant, memory killer, so it's just finished. So now, okay, you can use it and it's okay. So, about testing, this discussion, it's amazing how many hours we can spend on this. So I just put big lines here. Start with something simple. If you have a bug, so people can reproduce. Also, you have a simple test. You see, like I saw, you can get 4 million queries per second. If you get it, not yet on production, try to understand why. You can reproduce something and so on. Understand what you are doing by testing. So many people testing something old. So they expecting they test the system, but they will test something else. They can test the network because network is slow, so everything is slow. They go, okay. But if you have web network, so what do you expect from MySQL? It's amazing how many people can test a small data set. So when you ask them, what is your production? Oh, it's 20 terabyte. What? You're testing 1 million rows. What happens? You just testing CPU cache. It's small. You're playing inside, and so what is your conclusion? Because whatever else, it will be IO, and so on. So at the end, if you can move to your production, it's fine. If you cannot, well, try to implement something which can be representative. If you have, I don't know, rice intensive production, but you test only select. So what is your conclusion then? So if you get useless results, it's your problem. So to help, I don't know how many years ago, I started to build, because internally we have the same problems. People want to use Sysbench, they try to compile, it doesn't work, or whatever. They try to run a script, it doesn't work. You move on ARM, it doesn't work, it crashes and so on. So I shared, I implemented it internally and I put it on internet, so you can get it also on MySQL dev site and so on. So all internal different teams in Oracle using this. So just a bundle, it's a turbo, you have Sysbench inside, all the script you want. You just run it, so you have prepare script and run the test, and that's all. So well, also, there are so many options in Sysbench, so you can be lost inside. So I just take the problem opposite, so I just generated tons of scripts, shell scripts, that generated by another one. So in the script name, you have everything. It will be prepare 50 million, 8 tables, InnoDB, and so on. And then you will automatically write 8 tables, random, prepare a statement, transaction, and so on. So by the name of the script, you know what you run. So customers, then they are not lost with this. Now, starting point. That's amazing. You should really go, okay, you have a system, you don't know what is it, okay? Something new. So try to go by simple steps first. So will it already, you have a real good network, so this system is already ready for something realistic. So don't use a small, so at least 20 gigabyte, or depends on the memory of 100 gigabyte. So you can start with point select. So it's extremely simple queries, but it will give you an idea, okay, what you can do on this system. Is it working? So it's, again, So you can get 4 million, you can have 2 million queries, you can have 100,000, but depends what is expectation for this system. So you need to decide from the start, will you use prepared statement or not? Because on small queries, you can get 20 to 30% improvement. If your queries are pretty big, so probably not see the difference, but you can impact. So you need memory for prepared statement and so on inside. And then start with Unix socket first, before to go to network and so on. You will get an idea about what you can get from the system. Now look, I explicitly don't give you names of the vendors. So it's different hardware system. Both tested MySQL are, wow, we are winners, because they are all tested with Unix socket. Okay. So mostly have the same performance. So it's, let's see, 1 million something, 6.8. So I asked them, okay, please use that Unix socket, but also test IP core. So this one is okay, expectation with difference not big. Another one was surprised twice, why it's twice lower. I said, guys, you urgently need to fix your network problem because once you move to network test, it will be bullshit. It exactly happens. So they stopped all the work, and for 1 year they're fixing the whole stuff. They did not realize they had a big problem. So IP port is still local, right? It's a loopback, but it was also IP stack already. So there was IP stack broken, network had broken, and so on. When they started to propose their system to real customers, it was holy shit. Nobody wanted. So it's also about efficiency and report time, response time. So when you start and it's still on in memory, it's read only, okay. If it's bare metal, think about you may have new impact. Probably you are better to use CPU affinity. Probably you are better to use virtual machine on your system. Well, I think it's stupid, but MySQL license is by server. So if you have 256 cores, you can run so many VMs and still the same price. So what's people do today? And it's fine. So in fact, you can bind on MySQL instance to different cores. You can use virtual machine or so on if you want. Now, if you run on VM and you don't know what happens around, pay attention on CPU still because, Amazon stake, right? So you're running on your small VM. Then you share your memory with others. So in fact, it's the same host, like you have different VMs. Memory is the same. Memory access is going by the same rules. And you can see CPU still time just because some of your CPU cycles will be used by another VM because you share L3 cache, for example, or something like this. There is always something shared. Single thread results matters. So that people don't want to use single thread at all, but it's your baseline for response time. It can go only worse because if your load is growing, okay, you have highest throughput, but you will always increase on response time. If it's too much, keep in mind it's entry ticket, right? So if your response time is bad, it will be bad. Now, about malware. So this is pretty amazing. Who is using glibc malloc in production? Nobody. Gmalloc? There's nobody. TC malloc? Wake up. So, big surprise for Linux team. If you use glibc malloc, so well, it has memory fragmentation. So this is just to prove to guys, okay, during 1 week, round test is running, just look at the same stuff. We know that there is no memory leak in MySQL, but you get 10 gigs increase in memory, finish it by out of memory killer at the end anyway. Comparing to tcmalloc, this is tcmalloc, so it's old version, new version, so it was internal validation test just to see, okay, it's correct, still correct or not. So you see, comparing to glibc malloc, it's day 9. Why? So my preference was for tcmalloc. Because gmalloc, okay, it's always, so it doesn't have memory fragmentation, fine. But you may have this jumps in allocation. So gmalloc is trying to do everything fast. So it's focused on your performance and not on memory allocation. So in production, you see, this is when you change the focus. You want performance, but you want stability. If your MySQL server killed by out of memory killer, shit. Even because you are going faster, it doesn't matter anymore. If you kill it, you have a problem. Now, SSL. Amazing story. So first of all, if you do reconnects, well, like many websites use it before, you know, so every query will connect, reconnect, connecting the strings. So you see on this, it was 48 cores server, so it's kind of, you can do more than 1 million queries per second. When you do reconnect, it's already on 100,000, okay? When you add SSL inside, divide by 10 again. So when you do reconnect, you divide by 10, you add SSL, divide by 10 again, so by 100. So this is when you enable SSL, but it's when you locally on Unix socket. The difference always, you know, that's why you need to test real stuff. On network you have network latency, depending on your own network you have in the lab or in production. The story can be different. So it's no more 10 times. It will be 3-4 times difference. On high load, it will be smaller, but still. Now, on top of this, also depends which MySQL OpenSSL you will use. Anybody still use OpenSSL 1.0? No one? Good guys. So this is a holy bottleneck, so even don't think about it. OpenSSL 1.1 is the best, but not supported anymore. Now, so you have OpenSSL 3.0, which is delivered, but it has regression comparing to 1.1, okay? So some improvement came with 3.1. So I don't know, Karin, say something?
Yeah, there are improvements, but
so our guys working directly with OpenSSL team, and well, they pointed them on problem. So there is work in progress. I hope it will catch. By expectation, what it will be better, right? So if 1.1 better than 1.0, by 3.3 is not better. So let's. So this is read-only. Now we move into read-write. What is your preference? XFS? ext4? Okay. So ext4 has a big problem in the past. I don't know if it's fixed or not, but it still has a problem. So particularly on low mid-range load on IO. So something strange happens, but it's pushed by Google, by Amazon, because they expected to have atomic rights on this. It's not really atomic rights. You can still lose your data. So be very careful when you want to use the right stuff. So I think once Oracle team will, so it's the code is already pushed. So it's accepted. It's in kernel 6.14, I think, or something. Read latency. So this is first stuff you can do. So you can test. Well, I have a special stupid program to do this, but it's with Oracle Cloud team. So I pointed them we have problems inside. So they only want to use FIO. So okay, you have a script for FIO. Do this. So you can test directly your storage, just a device, to see. So you see, it's worst case for redo-log mode. Redo-log, the smallest block size can be 512 bytes. And what you do, so you write and you flash. You write and you flash. You write and you flash. Each storage can be different, you know. So in the lab, for example, it was amazing. So Oracle shipped some new storage drives, big drives, very performant on the paper. But when you run the test, you see on your read-log latency was 10 times worse. So all QA tests were just shit. So nothing to do there. What happens? But you have a bad drive. So bin log, you recall the graphs, right? And now once you move to IO bound, so this is critical. Okay, use at least 1 terabyte of data. Well, at least it should be 4 times bigger than your memory you have, okay, or your buffer pool. So at least it will be representative. So think about change buffer. You will see a graph about this, and you need to monitor. You have no choice here. because final number can be fake. So just because you may get really fake results, because you may have some data will be better cached than others, and if you see performance improvement, but your I/O activity is not following, well, I should put a slide here to give you a reason, but well, it's easy to understand. You have performance improvement, it's going up, and you don't have more usage on storage, so it's not because of storage. You have I/O-bound workload, storage is not following, it's fake. So just randomly some data will better cached than others, and it's all. And you cannot say, okay, this configuration would be better. Just your test needs some changes. So change buffer, just to give you an idea, OTP read write or TPCC, you can see it's when you enable change buffer, so particularly on high load, it's up to 20% improvement. So it's pretty nice. Compression, it's transparent compression. So how many years it was implemented? Sunny, do you recall? Sorry to wake up you. It's probably 10 years ago it was transparent compression. So there are people blame it, so it's not stable or something like that. So it's based on punch holes of file system, and well, it's complicated. So in fact, we delegate compression to file system, but it's in the right way. So in fact, we do compression on I/O level. So we'll compress on the write. So if we can compress the data, so we have 16K page, and it will be compressed to 4K, we'll write 4K, and 12K will be used for something else. So up to 4 times we can compress. But, well, it depends on your data. If it's favorable for compression, we can get gain. So I made changes to sysbench, like you get percentage of random data inside. So more random data you have, it's harder to compress. So if it's 100% totally random, so compression, it's not possible, So it's not magic. If you cannot compress something, then you cannot compress. You just lose your CPU cycles, and there is no gain. But if you have a good compression, so like even 50% data only random, but something else can be well compressed, you always get a gain. So it can go up to 50%, we see here.
There is one caveat. Some file systems, it can take very long to drop the file.
Thank you, Sani. And so Facebook sent us a patch in the past. So for file system, in fact, what the problem was, when you do delete of, well, let's say you have 1 terabyte of data, okay, I want to now to drop this database. It has a lot of punch holes, and this drop can take 1 hour. In the DB by design, if deletes on link system call did not give you return quickly, so we suppose there is a crash on the system, in the DB will crash. So this was changed. Instead to do the unlink on the file, we will do just f-advice, and we will trunk the tail. So progressively we'll trunk the file, and so we don't do a link directly, and then at the end it will be, we will remove and without waiting. So okay, it will take time, but will not crash, okay? The problem then, so I worked with XFS team on this. There was no guarantee if in the middle of this delete, you have power reset. It's still possible, then your file will be never deleted, and you don't have reference to this file, it will be somewhere. So your place is just use it, but you cannot drop it anymore. So all the stuff was fixed. So I tested, it's not the latest kernel yet, but so it's, I think it's also on upstream, on Linux upstream as well. So delete is taken 1 second, but in background, so XFS will continue to delete the file, and even if you have power reset, it will continue. So it's just clean story, no problem anymore. It's fine. So before to move, so our idea, yes.
About this deletion, is there any way to track files to be deleted background in XFS?
No. So in fact, the only way you can see, so you can start a command df to see the space you have, and you'll see it on the your space is going back or not. There is no any stuff. So you see, well, we have what we have.
Yeah, the concern is you schedule degradation for a while and you you don't know why. That's why I asked.
Agree. So well, that's why XFS team asking why you don't do this on InnoDB level. You should do your own compression. So, yeah, okay, fine, but why you already have punch hole? Why we can use? So well, it's Apple and
When is it safe to run? To say new SQL, but nobody's running yet.
this one.
When it's get fixed in XFS local, you need to know which run.
Yeah. So well.
You have an idea.
Right now, we started again discussion with XFS team, to be sure that everything is fixed, and I want to do some real stress test, with power reset and so on, and just be sure before we can really propose to people to go in production on our Oracle Cloud probably first. Yeah, look. So well, you see, it's not for Oracle Cloud. Probably it's not good because with compression you lose less storage, so they lose money, right? But well, generally, okay, you have improvement. You reduce network bandwidth, storage, and so on. So this is just a short list about what to do. So we start with in memory, 100 gigabyte or 20, whatever. If you want IO bound 1 terabyte, so just test the list to execute for your testing, and just keep in mind that it's about system evaluation. So of course, if you're looking for regressions or some problem in MySQL, okay, so you can do something else. If you have a lot of time, so if my time was unlimited, well, I know retimer never come and we never die, so we can run it forever, right? But you always block it by time. So you need to realize, when I start a long running test, real evaluation, it can take 1 week. If you have 1 week, if you have only 1 day, so you decide how many tests you can do. And for fun. So these are 3 years old results. So well, I hope I have no problem to share it. So about Amazon and Oracle Cloud, so I was curious about, okay, so what we do, what they do, where we are. So red line is Aurora with binlog enabled. Okay, so you recall that binlog has an impact and so on and so on. And we have green line, Aurora without binlog. So you can see that, okay, they do something good with RDS, supported so well. I was surprised at how shitty configured this RDS. In fact, it's used by default. It's everything done to show you need Aurora. Well, if you improve RDS a little bit, you have better performance. It will be even better than Aurora. But if you deploy your own MySQL on EC2 system, so they have this, well, it was 3 years or 4 years ago, they have R5B, so it's faster than others, so you can get much more. So in fact, you can easily be better than Aurora with all the security, read-log flashing, big-log flashing, so everything in it. So, and then, well, I was surprised, so comparing to, we did not make much effort on this side, on Oracle. Just standard, well, at least on Oracle Cloud, it's transparent, bigger storage you use, more IOPS you have. It is the same, well, price is only about size. You cannot pay, like here, this shape was with IO, how they call it. So we pay explicitly IOPS, so provisioned IOPS, right? So you can pay more, get more, but, well, in fact, performance was much more better, especially when you have X9 shapes with Intel. Now we have E5 shape also, which are running on the same speed and so on. So you see, this is Aurora. So I limited this test to 2,000 users. Here it was 8. So Aurora claiming to scale up to 15,000. Okay, nice. Where is it? So here is what you have with Oracle Cloud. And my biggest surprise was about price. So 3 times cheaper. 3 times cheaper, transparent than what we have here. But well, this is all in memory, right? When you go to IO, so you have 1 terabyte. So it's still about 16 cores systems and 256 gigs, so 1 terabyte, so you cannot put everything. So you see Aurora is well, red line, green line, so you can see all other systems can do better. What happens to RDS? See? So if you call slide about them, what they do, I don't know. On this side. So something broken, and well, I was happy to see, okay, Oracle system was still more efficient, and 0 effort, really. So well, 0 effort now, right? So all the stuff we made before, understand this malloc story, all this holy shit with Stripe and so on. So once it's done, it's transparent. So today, MySQL service is just running like this. So you enable your MySQL instance, you have all this stuff, and you just fun. So, hope everything is more clear for you now. And so I have just in the entry code, if you need links, all the graphs how we build. I have my tool, so it's everything shared on internet, benchmark it as well, so you have blog post and so on. So, and just to finish with 5 work about 30 years of MySQL. So, well, if I know there will be cake, I will take a photo, but well, this is my cake. Yeah.